All right, it's recording, and there we go.
Perfect. So welcome all. As explained, the idea is also to kind of have a session where we talk both of to those of you that are new to MISP and explain the absolute basics of what this is. But we're going to try to fast track that and get to the more interesting parts about how to create a report, some of the advanced features that deal with sharing and with anonymization and so on. So we're going to talk about those things during the entire session. If you have any questions at any point or anything, if something is not clear, please let us know about it either in the chat or just, I think there is a raise hand function here that you can use to let us know that you have something on your mind, and we'll try to answer it straight away. So a bit about the agenda. We're going to be talking, as mentioned, a little bit about the introduction. So what is MISP? Why is it there? What does it do? How did it come to be? Then we're going to have a session where we talk more about communities and how to have useful information sharing going on in your community. Then we're going to have a quick look at the different data models that MISP uses. This is mostly important to get some of the basic concepts out of the way so that we are speaking the same terms when we're talking about data in MISP. And then we're going to have a practical part where we're going to encode a report, see how to create data, how to contextualize data, and how to actually decide on who to share it with and finally share it with the community. We're then going to see a little bit about more about the sharing aspect and more about the collaboration aspect. So how can you work together with your peers, with your other community members? How can you inform them about improvements that you have for the data that was shared by them and so on? And then finally, a little bit about how to actually make use of all this data. So if you are part of the GSMA MISP community, how can you actually fetch the data that's relevant to you and how can you make use of it? And then we're going to have a Q&A session at the end where you can ask whatever else you have on your mind. So a little bit about how this whole thing started for us. So this is going to be a bit repetitive for those of you that have attended any sessions before. But basically, when it comes to MISP, the idea that we're trying to get across is that it started as a really small tool for a specific use case and has been growing for the past decade, basically. So initially, we had something called the Malware Analysis Working Group, which was a bunch of national CSIRTs and military CSIRTs working together. And what we found was that we were all being targeted by the same, at the time, nation-state attack. We're working on it in our own silos, which is pretty typical, especially a decade ago, how most certs worked. We were basically working on our own internal incidents. And if we had these regular meetings and so on, then we shared the outcomes as kind of a post-mortem, and that was about it. But one of the things that we noticed during this particular attack that prompted this entire process was that the attacks were extremely similar and extremely high complexity, targeting our different organizations at the same time. And that meant that we were basically spending a lot of work on analyzing and figuring out what was actually happening in our networks. And this process could have been sped up quite a bit if we would have had sharing in place from the get-go, and if we would have shared our initial outcomes and worked together on solving the issue. So we actually ended up having a lot of duplication of work. So this is the type of issue that transfers to a lot of different sectors and a lot of different types of concerns. And this is how MISP was growing over time. So this all started as a small private project of a chap called Christophe van de Plas, who was doing it as a side project, as a proof of concept that later on became MISP, and that grew over decades. Nowadays, we have quite a few different communities involved. So the telco communities is one of those big communities that is driving the development in a sense, that also giving us feedback on what should be included in MISP, how to improve it. So we as the people behind MISP, we are really looking for feedback on this. And one of the main reasons why we do sessions like this is so that we get the feedback that we need in order to improve the tool so that it works for your use case. Next slide, please. So just a few sentences about us. So both Sami and I work for an organization called Circle. We're the national CSIRT responsible for the private sector in Luxembourg. And basically one of our mandates is to build security at large for the private sector. So that means that we're building a bunch of open source tools, we're generating data that can be used, so we're informing a lot of organizations about threats that we're seeing, and that's basically our main duty in this sense. As Circle, we're also basically the main driving force behind MISP itself. So we're funded to also do the development of the open source tool. We're funded both by our government, so by our Ministry of Economy, as well as by the EU via CEF projects and so on. So that's basically just a very quick explanation of why we're here and what we do. Now, when we're talking about MISP, we're actually talking about different things. And the interesting thing and why we're talking about the separations of the different components of MISP is that we basically want to get feedback and additional output from the community in terms of better contextualizing information, building vocabularies that you already use in your organizations, so that we can make it easier for you to work with it. So when we're talking about MISP, there is obviously the MISP software itself that we're going to be seeing in a moment, as well as a bunch of modules around it that deal with connecting it with other tools, translating data into other formats, and so on, and tools that allow you to interact with the API. Now, on the other hand, we also, the MISP project itself contains a bunch of different libraries for contextualization, for knowledge-based elements describing information about threat actors, about different types of attacks. We're going to see a telco-specific MISP Galaxy, so that is basically a knowledge-based library of different attack patterns that we're going to see that target specifically telco-related entities. And we have a bunch of different things describing things such as the format of MISP, how to composite more complex objects in MISP, and all of these are also part of these libraries that we're sharing. Now, besides the tooling and the libraries, we also have a bunch of materials. So if you're interested in legal compliance of MISP and so on, we provide a bunch of materials for that as well. So just let us know afterwards if you're interested. It's all up on GitHub, but if you want to find something in particular, just ping us in the chat and we can point you to it.
Yeah, talking about the materials, all the slides and training materials are available in our GitHub repository, and the slide of this session will be given to Leonie so that she will be able to share them with you if you're interested.
Exactly. A bit about the governance itself. So just very quickly. So basically, when we're building MISP, we're taking feedback from a bunch of different sources. So being an open source project, obviously GitHub issues is number one thing that we include. So if you have any concerns about issues that you're seeing in MISP or ideas of what to include, that's your first stop basically on how to reach out to us. But besides that, something that really helps us is, and this is a struggle for anyone doing open source, is that that you never know the weight behind the request in a sense of how many users are affected by a defect or something missing from the tool. And this is where organizations like GSMA are an absolute game changer for us, in a sense that you can reach out to GSMA and then they can relay that request on behalf of the entire community to us. And we know that this is a request that really has a lot of users behind it. It's not, for example, a student trying out MISP for the first time over the weekend and having an idea that might be useful for the community or not. So by all means, use this mechanism, reach out to GSMA if you want anything included in MISP so that they can let us know that something is missing. Also, basically, any training session, any webinar, anything that we do, one of the main outcomes that we want to see out of that as well is also feedback. So if you're seeing something that doesn't make sense to you during the session today as well, just let us know about it. Okay. So we're going to talk more about this in depth later on, but something that to already start out with is that anything that you do, that you share in MISP, you keep ownership of, and you basically can decide who gets to see the information. We're going to see the exact details of what mechanisms you have in place, but this is something to get out of the way already from now, that MISP operates on different levels of sharing in terms of where you distribute data. That means that you can decide for certain data points to share it with a closer community, to keep it internal to your organization, or you can share parts of the package with a broader scope of recipients. But we're going to see that more in practice. Next slide, please. So something that Leonie already mentioned, and something that we were going to be going a bit more in depth in today, is all the different mechanisms that you have in place to ensure that the sharing happens in the way that you imagined it when you created the data. So one of the things that we're going to be talking about is pseudo-anonymized sharing, for example. So that means that that there is a mechanism in MISP in place that you can use also in the telco community to, for example, entrust information to be shared through GSMA. So that means that your name will not appear on the information. So if you have something to share, but you don't want it attributed to your own organization, and you want to make sure that that you remain anonymous in the sharing, then you can basically use GSMA to share the data under their name. So, so one of the biggest blockers that we're seeing in some communities, ISACs and so on, is really the fear of any repercussion in terms of for example, loss of trust in your organization and so on, if it's revealed that you might have had a breach, for example. Still, the sharing of the technical indicators to protect your peers is important. So because of this, we have this anonymized sharing mechanism in place. We're going to see how that works in a bit. Something else that we want to encourage, and something that is still underutilized in a lot of communities, is the collaboration aspect of MISP. So the idea that you can improve the data shared by your peers and also provide counter-analysis to what was provided. So that means that if you're seeing that an organization in the GSMA community is sharing information about a specific type of attack, and you have more information about that same attack because you were hit by it, you're seeing different data points, seeing slightly different techniques, then you can basically create extensions to the original report and include your findings in there. The idea is also to that those that are affected by something, that they get the full picture as soon as possible. And by interlinking the different data packages that you're sharing, you're basically showing that there is a linkage to investigate for someone that is hit by either of those components. Something else that Leonie also mentioned is one of the big advantages of using a system like MISP is that you can spin up your own instance in your own network. And instead of using the hosted instance of GSMA, start synchronizing information with them. This means that, for example, searches that you're running against your data set will be done locally on your network. So you don't have to worry about leaking out information by searching values that turn out to be sensitive. So you can do that on premise on your side. You can run your own enrichment tools, connect the services that you already subscribe to, such as feed providers, various different reputation tools, and so on, to MISP directly in your network. Now, something else that is that we should probably touch on a little bit is you probably, or some of you have already seen the issue that you have your tooling and your investigation in a network that is not able to connect to the GSMA MISP, for example, perhaps because you're doing it on an air-gapped network, you're doing it on an internal network where you don't want to have communication with the outside world. Now, in that case, we have a mechanism in place where you can basically ingest the data coming from other sources without having a direct connection, by first dropping it into what we call a MISP feed, and then ingesting that MISP feed even from local files, from a local share, and so on. Now, with all of these different sharing methods that we've discussed until now, one of the things that we also put a lot of weight on is basically the ability to filter the sharing in both directions. That means when you have information in on your instance and you want to share it out, you can apply a bunch of different sharing rules of what gets shared, what gets filtered out in the sharing, and so on. And same thing on the recipient side. When you're pulling in data from different sources, you might only be interested in certain topics, for example, or you want to exclude data that you think is of no use to you. So generally what you will see in a lot of different MISP communities out there is a large amount of data, and a large amount of data that basically serves different concerns and different requirements. And the idea is that you can map those requirements to these filtering settings and be able to receive or to send out the information that is relevant based on the requirements. So this is one of the things that we're going to talk a little bit about on what you can do there. Now, something else, and this is one of the biggest worries whenever it comes to connecting to a lot of different communities and fetching information from different sources, is diluting the useful information you have with basically what you consider junk in terms of your operational needs. Now, we have a system in place in MISP that allows you to use remote sources. So if besides GSMA, you're connecting to other sources that have perhaps lower quality information, or information that's just tangentially touching on what you're doing. In that case, what you can do is you can cache the data set of that remote instance, and you can do lookups against it. It means that when you're starting describing an incident that you're seeing, you will immediately get correlations on the different data points on the other instances. So that means that you're seeing, okay, this is something that might be something that my partner already knows about. I can pivot over to the data set that they have that is relevant, pull the data in, and then start working with that. So we basically also have a support for setting up multiple internal MISP instances using the same mechanic that allows you to have, for example, collection MISPs that collect raw information, and it allows you to, from your operational instance, pull in data from your raw data instance whenever you're seeing a correlation to something that you're currently investigating, for example. Next slide, please. As for the sharing itself, MISP operates on the concept of everyone being both a consumer and a contributor of information. That means that that we kind of want to move away from the paradigm where you have feed providers and consumers, and in MISP you're both. So that means that whenever you're consuming all the information, you always have the way to feed information back to basically provide your own perspective or to create your own information packages. Now, when it comes to MISP sharing, each of these different MISP instances can interconnect with each other and push and pull information based on those filtering rules that you have configured. Now, one of the things that travels along with the information is also, for example, improvements. So that means that even though nobody can modify the data that you have created along the chain, they can provide their own feedback. And then that feedback is propagated back to you, and you can then make choices of whether to include that information in your data package or to discard the changes. So also the idea is that we want users to be onboarded in gradual steps. So the normal process of getting started with MISP is you connect to a hosted instance. So in this case, the GSMA instance, and you start interacting with the data there. That means you start exporting the data in different formats for your different tools. You start viewing the data, you start correlating the data, all on the hosted GSMA instance. Now, at any point in time, you can decide, now I want to go to the next step, install my own MISP, connect to the GSMA instance, and start pulling data in and working on my local instance with the same data. So basically, the idea is that to start out, you don't need to install anything. You just log onto the system, start using the data, and then you can ramp it up over time if you wish to do so at all. Next slide, please.
Just before switching to the next slide, to explain this graphic, which can be a bit confusing. So what we have here is this gray MISP instance basically start with this initial event. And then you have either connected MISP instances with different synchronization mechanism, or even users having access to this gray instance that can contribute and enrich and improve this event. So for example, in that case, you can see that this instance adds a small data element or contextual element and so on. And so in the end, with this collaboration mechanism, it gets propagated along the different MISP instances, and you end up having a much more interesting event. So yeah, that was just a side note regarding this, this graph.
So something else that we really want to encourage all of you of thinking about is that one of the initial use cases of MISP, and one of the ones that everyone is still using MISP for partially, is to build defensive signatures. Now, these are very often done by basically building a set of indicators and sharing that set of indicators as a single block. Now, the disadvantage of that is that whenever you're receiving information like that as an analyst, you don't really know what the story behind the incident or the investigation was. Now, one of the ways that we overcome this is that we're building connected graphs and more composite objects in MISP. From detection perspective, there is no difference. You're still getting your indicators the same as before, but you're also building the context of how these different data points are interlinked. So if in our domain as a CSERT, we get information about malware being executed, we really want to see different phases of what happened first. How did this malicious sample interact with the system? How did it use the different network data points that are also included? Was something used for exfiltration? Was something used to download additional payloads? So all of these different data points, when you put it in context and when you build a graph out of it, gives a lot more meaning when you're looking at the data. So here's a small example of one of those scenarios where we basically had an information, we had an incident including some fraud that was traced to a person that had a certain bank account. The moment that you put verbs in between the different data points, and you say that this is the owner of that bank account, for example, this person, for example, that this malicious sample drops a secondary artifact, which then, for example, downloads a specific payload from a C2 server. So these kind of interactions allow you as an analyst to really work with the data and to really understand what actually happened during the incident, and also to tune your defenses accordingly. So that means that if you're seeing that certain events followed other events, then both as a threat hunter or as someone that is working on mitigation already knows what steps to anticipate next. Sami, I think you wanted to...
Yeah, exactly. So something that you can also notice is that you can also express and link data points together if they make sense. So for example, in that case, instead of having like a raw table of data, you can see that we contextually link it into a container, in that case, the bank account, which can contain multiple data points. It's also a way to express and to give more sense to whatever data you are entering. But we'll come back to this later on in the presentation.
Mm-hmm. So something else that is of great value is whenever your community is sharing information, one of the things you get automatically out of this entire process is correlations. That means if I'm entering any data point about a certain type of attack, about a certain type of infrastructure, then immediately if that thing was seen before in the community, I get a correlation. Now, very often when you're seeing different types of attacks originating from a certain source, you can basically already check what sort of other attacks were coming from the same source. This is something that I should be investigating in my own network. So these are the type of questions that can be easily answered by pivoting to what your peers have already done, to the data that was shared by them, and to finding out what sort of next steps you should be looking at. The other thing is very often we use correlations also to confirm our own analysis. So that means that if we analyze an incident and we see, okay, a lot of these different data points in our incident correlate with a past incident, then we can check, and if we see that the outcome of the incident response was the same as what we're getting to at the moment, it already confirms that we're probably on the right track. So you basically, one of the things besides just a sharing tool is we also use MISP in our analysis process, and I highly encourage everyone to start with including the information that you're extracting during your investigations already into MISP with the pooled in data from the GSMA community, and you will immediately already see those links that help you with your analysis so that you don't spend time on something that was already analyzed before. Okay, next slide, please. So besides just sharing the data itself, one of the most critical elements of information sharing is to be able to contextualize the information. So that means that besides just sharing individual attacker infrastructure data points or indicators that you're seeing, also to describe how these different data points are relevant. There are a lot of different frameworks that allow you to contextualize information. So if you browse around in MISP's Galaxy and taxonomy libraries, you will see a bunch of things that either might make sense for your use case or not. We're going to see some GSMA or GSM specific use cases later on in the presentation, where we talk about different frameworks that support what you're doing. So let's leave that for now. So let's talk a little bit about the different tools that we have in MISP to ensure that the data that we enter or that we ingest can be brought up to a standard where it's really usable for day-to-day consumption, for automation, and so on. So obviously, one of the things that helps us is correlation. So we already talked about that, so I'm not going to go more deeper into that. But basically, having the cross correlations between different data points already drives our decision-making on how we analyze an ongoing incident. We also have a feedback loop in place. So that means that whenever you're building detection rules for your community can provide feedback on whether they have seen those different data points in their networks, whether they're seeing the same type of attacks, by a tool called Sightings. So Sightings are basically just saying that at this point in time, I have seen what you have shared and it was relevant or it was a false positive. Now, one of the things that you would normally do is if you have automated tools looking at your logs, looking at your different network flows, then to automatically feed this information back to MISP so that you can put timeliness on the different data points. We're going to talk a little bit about lifecycle management for indicators in a bit, but the important thing is to know is that one of the deciding factors on whether something is still a relevant indicator is whether it has been seen in recent times, or if it's something that hasn't been seen in a year, maybe not that relevant anymore. So sightings provide this additional timeliness to the data that is being shared in the community. Something else, and this is one of the biggest concerns we're seeing from organizations, and especially for service providers, this is an especially nasty subject, is how do you deal with false positives? So when it comes to protecting your users from harm, and from blocking malicious resources from being able to interact with your users, then the fear of blocking something legitimate is obviously much higher than for a lot of those endpoint organizations that just consume data for their internal protection. So if you start blocking, for example, connections to popular websites or popular services, then you might end up in getting some quite negative feedback from your user base. For this, we have some systems in place in MISP so that we can manage those obvious false positives. Very often, false positives come in something where an analyst looks at the data and says immediately, okay, obviously Facebook.com, for example, shouldn't be blocked because then I'm going to have some annoyed users. So what we wanted to do is to translate this analyst knowledge into these different libraries that we use in MISP. So we have a massive amount of libraries that contain those typical false positive values that show up in data shared. Now, I also really encourage everyone to build their own false positive warning lists. That means, for example, you don't want to end up blocking your own infrastructure or services that you rely on. So just create these false positive management lists so that you can exclude those from ever going into your detection or your blocking tools. Now, besides managing false positives and putting timeliness on the data, you also probably have access to a bunch of different services, be it internal or external, that you pay for, that allow you to get more information about each individual data point. So this is what we call the enrichment systems. So if you know any such services, you have a bunch of different connectors in MISP. You can connect your MISP to these different services via API keys, via different URLs or whatever you use to connect to them. And then basically loop the different data points that you create through these services to enrich them with additional information. On top of these different data sources, there are obviously also different integrations with different tools for ingesting data from different sources, but also to feed different types of tools out there. So this is kind of a decoupled tool set in MISP. So that means that if you want to build your own integrations, you have your tools available in MISP to quickly build translation layers, and then you can start feeding your different internal tools, be it homegrown, be it something vendor-specific, with the data that you receive in MISP. We also have a bunch of different APIs. We're not going to go too deeply into that now, but basically anything that you do via the interface can also be automated in MISP. So if you want to go through the full stack of creating data from a ticketing system that, for example, or from different ingesters that you have, it's pretty easy to script so that you create that data automatically in MISP. Now, on top of that, once you get this large set of information in your MISP from your community, from your own indicators and so on, then one of the challenges is to figuring out what is fresh enough, what is useful enough to feed to your different protective tools, detection tools, and so on. And this is where indicator lifecycle management comes into play. So we have a full tool chain that allows you to create scoring models, that allows you to score the different indicators based on a bunch of different factors like context, the source of information, the type of information, sightings received on information, and so on. So we're not going to go too deeply into that. If you're interested in documentation about that and slides about that, just bring us and we can point you in the right direction.
Yeah, we can also talk about it at the end of the session if some people are interested.
Sure. So just very quickly, and we're not going to go too deeply into that. When it comes to sightings, basically you can feed information back. I have seen this as well. And the other thing that you should also consider is also feeding information back, that I have seen this, but it generated false positives for me. So this is something vital for the community to know, so you can do it via the sighting system. Although we have some screenshots here on how to do it via the UI, this is something that you most likely want to do through the API and in a more automated fashion. Just a small side note, if you're dealing with large data capture, so if you want to capture the entire flow of data in your network, and you want to cross-correlate it with MISP, there is a tool called SightingDB that allows you to store massive amounts of data points. So it's also an open source tool. It's developed by Devo. It plugs into MISP, and you will get the sighting information for each of your indicators based on your historic network flow, for example. So just something to consider setting up along with MISP. Okay. Now, something else that we haven't really talked about when it comes to freshness of information, very often the data that provides the freshness and the timeliness of the data doesn't come from sightings, but also from your own investigation. So one of the things that we want to do is for you to be able to describe the entire flow of an incident or a set of different events that happened based on also the when it was first seen, when the activity ceased, and to be able to draw a timeline of the different events. Very often what we're seeing is different links between different occurrences are not made because the data points are different, but they still happen at the same time. So there might be a linkage that we're missing in that case. So basically, the time-based visualization of the data allows you to see, okay, these things happened at the same time. Maybe there is a correlation between them. Let's investigate that. So just include this information as well along with your data to see that. When it comes to the indicator lifecycle management tool, just a very quick note on that. You have a lot of flexibility on how you configure it. So we do provide some basic models there, but the idea is for you to tune it yourself, depending on what you consider highly relevant over longer periods of time. So you can set how data should decay, how it should be refreshed by sightings, how long it should stay in your system.
Yeah, so we have pre-built rules, but it's really left to the user to set up their own so that it fits at best their use cases. Yeah, so the tools itself includes different mechanisms to decay, to set these kind of rules, and also include interfaces to set these rules visually and to simulate it on your dataset to see what you would expect if you were to run these rules. Yeah, so whenever you are using this system, the best is to use it via the API because, of course, that's how you filter out data that you don't want to see in your result set. Right.
Yep. So just a little bit about how sharing information in the community and some of the things that you should be watching out for in general. So when you're thinking about sharing, there are different scenarios that might make sharing relevant or reasons why you want to share information in the first place. One of the top things that we already mentioned a fair bit is sharing the outcomes of your individual incident responses, your investigations, and so on. So whenever you're seeing an investigation, one of the outcomes of any investigation is a set of technical indicators, for example, that can be used to detect the same thing in the future. So sharing that is one of the most obvious use cases. Another use cases, and something that we, for example, as a CERT do quite a bit of, is we collect information from different sources, be it reports coming from vendors, from OSINT sources, be it our different collection mechanisms where we have honeypots, sandboxes, all sorts of collection mechanisms where we collect information, where we make it actionable, where we infuse information with context, where we decide what is relevant for a community. And then once we get useful information package out of it, to sharing it back out to the community. Another use case is simply collaboration coordination. If you have an incident ongoing that involves more than just your organization, but you know that some of your partners are hit by it, get together and collaborate on the resolution of the incident. So we do that very frequently. As a CSIRT, we're called in very often for incident response at different organizations, where we collaborate, for example, with law enforcement, with other private CSIRTs that might have been, or SOCs that might be involved in the chain. And then we basically share our findings as we go along and discuss them through the system itself. Now, there are also a bunch of different community-related challenges to overcome. So let's have a look at some of these in a bit more depth. So for when it comes to incident response itself, one of the things that we do with MISP is we basically take all the data that we're extracting during the incident response, and we are storing that data directly in the tool. So that means we're even the initial findings, data points that are not for public sharing or anything like that, we directly inject in our local MISP instance so that we can cross-correlate it, we can work with it. Then afterwards, when it comes to the sharing, what we derive from this is only going to be a subset of the information that we included in our initial data set. We're redacting information about the victim, for example, we're redacting information that is not relevant for the community, and then we end up with a data package that is more fit for consumption by others. We also cross-correlate the information using the built-in analysis tools, for example, via different enrichment services, and also the other data points that were shared by others. Again, with the collaboration and coordination, we already talked about that, so I'm not going to go too deeply into that. You can also automate the process of basically actioning on the different data points that you're generating. In our case, as a CSIRT, this means, for example, sending takedown requests to different service providers. So we're basically automating this entire flow of encoding the information, figuring out what is actually the relevant malicious data points, and then informing the affected parties directly through the system. There's another tool that might be interesting for you if you're looking for leaks regarding your organization called Ale. So this is also an open source project that we maintain. The idea here is that you can collect information that is relevant based on keywords, based on different search patterns from a bunch of different sources out there. And it also has a connector to MISP. So when you're finding something useful, you can ingest it into your MISP and then share it out with the community.
Yeah, exactly. That's our small part of advertisement. So it's basically at the beginning, it was mainly for doing analysis, but right now it's much more powerful as it allows you to also crawl website, but also Tor-hidden services. Ingest all of this data. It can also come from different feeds like Twitter feeds or social media feeds and so on, which we are also using. And then based on all of this data, you can also analyze it, create notification, send emails, and push directly data to me. So it has very a tight connection with MISP in that regard. So closing the advertisement. But it's also an open source tool, so everything is available.
Okay, oof, this is a heavy slide, so sorry about that. So basically, once going back to the second use case, collecting all this information and making it actionable involves a lot of different steps. So as mentioned before, one of the things that we do is we want to include the context with everything that we share. So we want to basically even take data from third-party sources and enrich it with additional information on what sort of attack patterns are we dealing with. That really helps with aggregation afterwards and seeing trends from different attackers. And we want to include information, for example, on that comes from our own analysis. So very often this will be relevant for all of you when you're getting information from your peers, from feed providers and so on, is to also run your own analysis and your own perspective and include those in the data packages that you share out. Now, very often the end result of this is that we're aggregating this information. We're seeing different attack patterns, and we can basically build situational awareness out of it. So in an ideal situation, if you have good sharing flow in your community, you can ask questions from the system, such as, show me the different attacker techniques that were used in my region, on my continent, my country, and so on, against other peers over the past 3 months, and then compare it to what happened a year ago, for example. How much did the attacker techniques change? What should I be investing in terms of defenses? What should I be on the lookout for? Okay, next slide, please. As for the collaboration and coordination, I mean, there are a lot of different aspects that that you can collaborate on. It's not just the data itself that comes from incidents, but for example, if you're dealing with vulnerable devices, sharing information about vulnerabilities is also a key aspect, and also notifying vendors about it. So if you bring them on a common network and you're able to share this information all the way back to the vendors, then you can also start the entire disclosure process and so on from a much earlier point. So we've seen some successful communities that basically do vulnerability assessments for all the tools that they use internally. So we're talking about some large organizations that have dedicated teams for this, where the moment that they start the vulnerability assessment, if they're seeing anything suspicious, they already involve the vendor, both for validating the findings, but also to discuss remediation and then disclosure in the end. So there are a lot of these different aspects that you can collaborate on besides just sharing the outcome of incidents and events. Next slide, please. So when it comes to overcoming different challenges, there are a bunch of different things that might be specific to a sharing community, to an ISAC, and so on. And this is something that you most likely are also dealing with. So, for example, one of the aspects that we're seeing quite a lot is that there are needs to report incidents based on contractual obligations, based on legal frameworks out there. So the NIS directive, for example, sets certain rules on what needs to be reported. So you can basically use MISP also as a tool for that. So to have those reporting needs in place and to report back to authorities, to your community, to your ISAC information that you're seeing. Apart from that, one of the things that we're seeing as well is also the first step of collaboration, which is seeking collaboration with others. So that means if you're seeing something that you don't have the capacity or the capability to get to the bottom of, you can reach out to the community already with the initial information package that you have. So this is what I'm seeing in my network. Something is fishy about this. Can anyone help me? So you can get started, especially for lower maturity organizations or with smaller security teams. This is really helpful in general. So requesting help, requesting additional information, different perspectives, all of this can be done in a sharing platform. Now, we already mentioned pseudonymized sharing a little bit before. This is one of the other key aspects, is how much you share about the information being seen by you is another question that is going to be different case to case and from organization to organization. So leverage the fact that you're in a community where you have a central authority that will take care of information sharing on behalf of you if you wish to do that. So if you ever run into a situation where you want to share something with the community without your name, delegate it to the GSMA and they can share it for you. Okay. Now, on top of that, and this is something that you will see more and more, is sometimes new types of threats pop up, sometimes new types of concerns pop up that you might want to share that cannot be described currently in MISP, for example. So one of the things that MISP allows you to do, and that we're really looking into on how we can help there as well, is to be able to encode types of information that don't exist yet in MISP. So we've seen a bunch of different communities pop up with their own different use cases, different organizations that have a need to share, for example, mule account information. So this was in the financial sector. From border control, we've had requests to be able to encode information on seized goods or passenger records and so on. So if you're seeing anything that you cannot describe in MISP, let us know about it and we can include it. Or we can point you to the right direction how you can do it yourself and include the MISP without our intervention. So this is something rather straightforward to do in MISP. Okay, next slide, please. So a little bit about compliance. So we're not going to go too deeply into this. We basically work together with Deloitte and a bunch of other partners under a CEF project to map MISP to the different frameworks out there. So this means describe how information sharing fits into GDPR, how it fits into the NIS directive, and so on and some other frameworks. So if you have any questions in that regard, we have a GitHub repository for it with a lot of documentation for you. And if it doesn't help you, let us know and we'll update documentation to include your concerns that are not mentioned in there. Next slide, please. So Something else to consider is whenever it comes to information sharing, you will see that depending on the organization you're in, and even depending on the different team within the organization that you're in, different things will be considered as valuable information and something that you can contribute as well to MISP. So we're not just talking about fully qualified reports that are coming out of an organization. Sharing comes in a lot of different shapes. For example, sharing feedback on information, as mentioned before, is valid information sharing. Flagging false positives, asking for support. These are all different interactions in a sharing community that are part of the sharing process. So what we recommend for everyone is to not scoff at anyone that is not producing those highly usable reports from the get-go, but to also include them in the entire sharing and make sure that that you make use of those fragments of information sharing as well, just the same as you would from those fully vetted reports. Okay. So something else that you will see very often is, and this is a concern in most sharing communities out there, how do you deal with organizations that just ingest information and never share anything back? Now, this is going to be a little bit anecdotal, but from the different communities that we run the statistics, and only about 30% of the organizations that participate in our communities ever shared actively data. This might seem like a low percentage, but actually it's really high compared to some of the other communities that we're seeing out there. And even getting to this number took us having a community in place for 10 years. So our recommendation here is don't rush it, and also understand that there is value in recipients of your information not sharing back anything, but just using your data. Because the first thing they will share back, and that's a type of sharing that happens much more frequently, and the 30% there is feeding information back about something being wrong, for example, so corrections. We've tried to use your data, something broke, it generated false positives, you had an incorrect rule in there that didn't really work. So this type of feedback already improves the data that you're actively using day to day. So, so generally information sharing really includes a lot of these different layers. Now, one of the things that we really would advise against is putting quotas, for example, in place and requirements to share information, because this is normally a natural process. You have to, first of all, build enough trust to share the information. You have to have the maturity and the time investment in place to be able to share the information. So if you don't, if an organization doesn't, that organization can still be an active and valid part of the community over the long term as well. So don't worry about that too much. What we've seen, and that's one of the reasons why we really advise against it, is usually organizations overcome any requirements like that by either sharing like chunk or just sadly dropping out of a community. So don't try to force that. Next slide, please. There are also some other difficulties to overcome, and no tool will do this for you, sadly. But one of them is obviously trust. The good thing for you is you already have a trust relationship and a large coherent community in place. So for you, you're basically already there. So this should be less of an issue than for a lot of the other communities out there. There are also some legal restrictions that you might have. So you might have your legal team coming to you and asking you about how whether sharing any information that potentially might include something that shouldn't have been shared by user mistake and so on is really a good idea. In that case, always weigh the risk and benefit as well. So if you're sitting on information that might have saved your peers basically, and you're not sharing it, that might come to haunt you afterwards. Not just because of the embarrassment of this information coming to light, but also because we're all interconnected with each other, and the security of our peers improves our security as well. So generally, there is a huge benefit to have of having your peers protected as well. Some practical restrictions. I mean, one of the most common one is it takes time to share information. So this is obviously going to be true for any information that you share. We try to minimize this time investment in MISP, but there's still a long way to go for there. And you will have to invest some time, obviously. When it comes to coming to the same format, same vocabularies and so on, this is something that we can mitigate. So especially if you look at the GSMA community, there is a vetted list of taxonomies to use, a vetted list of vocabularies to use, and a vetted list of different ways of describing the data that is relevant to you. So when it comes to describing, for example, an SS7 attack, all of the objects and so on are already in place, so you can immediately get started with that without having to encode the information on how to communicate that. So there's a standardized way to do it. So in your case, that's actually quite easy already. There are, when it comes to contextualizing information, keep in mind that that sharing technical information is really a good start. So just sharing indicators is already helpful for your community, but you already should consider, how can I make this information more useful for the community out there? How can I describe what in this information package that I'm describing, what part of the information can be used for defense, and how it can be ingested, how it can be made useful for the other community. So make sure that you also contextualize the information also in this regard, to explain to the recipient how the information is useful for them. Next slide, please. Now, the other thing to consider is that there's going to be different types of expectations depending on whether you're producing information, consuming information, and which part of the community you're on. So generally consider different questions that you should be asking yourself. For example, as a producer of information, I should be asking myself, is this information really consumable by the entire community? How can I describe it better so that they know how to consume it? Is this information actually useful for the community? Or should I mark this information as only being useful to a marginal group of the community, for example? We have a community where, for COVID-19, for example, where we share information about misinformation campaigns as well as cybersecurity related information. Now, obviously, depending on the type of organization you're in, you might only be interested in certain parts of that. So this is where contextualization drives the decision-making of the recipient of the information. If you provide the context, they can make decisions. If no, then they will probably consider the entire dataset chunk. So this is highly important. Now, on top of that, also label your data on how it is to be used. So very often there is ambiguity when we get different indicators. Is this indicator meant to be used to detect incoming connections, for example? Is this indicator to be used to check local logs in our different endpoints? These are the different questions that you can also answer by better contextualizing the information. Now, on the other hand, next slide, please. As a recipient of information, what you should be asking for from the producers of information is to create information for you that can be easily filtered. So this is my expectation as a consumer of information. I want to be able to filter the information from my different workflows, from my different tools, from my different expectations. And also, I want to be able to tell, is this something that is fresh? Is it something that I still need to worry about? Or is it outdated information that you included as a historic drop of your previous investigations? Also, especially interesting, you have a community with a lot of different types of organizations here, with different maturity, with different capabilities. Think of also the organizations that might not be at the same maturity as you are. Include hints about what tools you use to make use of information, about what tools you use to get to conclusions and to extract the information. And perhaps if you've written your own tools, scripts, and so on, include those along with the data to make it easier for the other organizations to replicate the process. If this is basically something where you can bring the other organizations in your community up to the same level that you're at in terms of maturity, and you will get better data back from those peers in return. And then finally, the most important thing is we really like data that tells a story instead of just raw data points. Because very often data points change very rapidly, but the entire mechanisms and the attacker techniques don't. So they carry over from incident to incident. And being able to tell a story teaches the other analysts on what sort of expectations they should have in terms of or anticipation in terms of the next steps the attacker might make after initial step. Next slide, please. So false positive handling, we've talked plenty about this, so we can just hop over this for now, I think. Yes, very briefly to also consider, and this goes back to the contextualization point, is keep in mind that data can be used in many different ways in terms of, I want to use this to detect something malicious happening in my networks, I want to block something for my customers, or I just want to track how certain threat actors are operating. These different levels of information sharing or information usage rather, require a different level of having vetted information. So when it comes to blocking information reaching your users, you want to absolutely make sure that that data is really fit for blocking, because otherwise you will end up blocking useful services, you're blocking your peers, you're going to be blocking access to perhaps your own infrastructure even. So you want to absolutely avoid that. So you really want highly vetted, false positive proof information. On the other hand, when it comes to tracking attacker movements, sometimes data points become less relevant over time. Compromised infrastructure becomes cleaned up, for example. In those cases, those data points are completely irrelevant from a blocking perspective, but they're still relevant from an intelligence perspective in terms of enriching of how your libraries on how an attacker works. So keep these conflicting data sets in mind and make sure that labeling is in place to basically differentiate between them. Next slide, please.
All right. So I will take over a bit now. So what we will do right now for the 20-ish remaining minutes that we have is we will go through the MISP data model, both in theory and in practice. So we've already talked about some concepts like galaxies, event attributes, IOCs, and so on. So we'll see how it integrates in MISP and how you can create these in the MISP platform. So it has also a practical part. So for those who are already familiar with MISP, please bear with me. Maybe you will find out new data structure that we have added along the way. So I don't have the slide, so let me just take it quickly. Oops. Okay. Oops. All the way to the top. All right. So we'll go quickly over it. We will not go in depth in how the format is actually structured, like in how it's stored in the database or how it's JSON representation. We'll mainly touch and see the high-level concept that we have both at the data layer, so the raw data like an IP address, file hash, an IMSI number, and so on, but also at the context layer. So all the context that you can add to this data layer. So context like tags, tags from taxonomies, meta information with galaxies and so on. So the data layer is basically the raw data itself. So it's the indicators, the observable, and in MISP terminology, it's what we called event, attribute, or MISP object. And the context layer, which is as important as the data layer, because it's really how you can tell others how to use the data and what to do with it, and how important it is. And this context layer basically latches onto this data layer, as you will see. So to quickly come back to the distribution that MISP has to offer, we have few options. So the first four options are kind of easy to understand. So organization only means that every data that you create will only be visible by the organization that you have in MISP. So only by you and the administrator of the instance. This community, this one means every other organization that have a presence on this instance. So if you were to share an event on the GSMA instance, that means that you, the site admin, but also all the other organization having an account on this instance, so the GSMA instance, will be able to see the data. Then you have connected communities. This means organizationally, this community, but also all communities connected to this instance. So to apply it to the GSMA case, all other MISP instances connected to the GSMA instance will be able to see and to receive the data if it were to get synchronized. But once it arrives to this connected instance, it will be downgraded to this community, meaning that it will not propagate further. So it's really one hop away from the source of the data. basically. And all communities, this one can be a bit confusing. It doesn't mean that it's publicly available to the internet. It just means that it will propagate as far as it can in the network of connected MISP instances. Yeah, I have a diagram in the next slide, so I can explain a bit more. And then you have sharing groups. This is really a particular case. It's a distribution list, so where you enumerate the different organizations and instances that can receive and that can view this data. So it's particularly useful if you want to restrict the sharing to some specific organization. I think GSMA has some of them, for example, for the operator groups. But yeah, if you know about it, you will recognize yourself. And all of this distribution level can be applied at different levels. So for at the event level, which is the container basically of all the data that you can have in MISP, but also at attributes level, so the smaller data piece that you can have. So with the diagram, we can see that we have one MISP instance with this community, so the data will not leave the instance. Then connected communities means one hop away from the source, so you can see that these two can receive the data, but not the purple and the green one. And all communities means that it will be shared as far as it can in the network of propagated MISP instances. And the last one, the sharing group, where you can see these 5 organizations with their logo. You can see that the sharing group works both on an instance, but also on connected instances. So if you enumerate that organization, for example, this one and this one, are part of the sharing group, it will be also shared with these instances, and only these organizations will be able to see the data on these instances. All right, so now to have a quick look at the data layer, we have a bunch of different data points. We'll go over them with some screenshot to show how it works, basically. So you have events. Events are really the base thing that you have in MISP. Whenever you want to start encoding data, you will always start by creating an event. It's just a way for you to have a container to contextually link information together. So the second one, the most common, is the attributes, and these are the individual data points that you have. So they can be either indicators that can be used to be fed to IDS, for example, or to be blocked, or they can also be supporting data. So for example, it can be ticket numbers, it can be comments, it can be source of the information, and so on. Then you have objects. MISP objects are custom templated attribute composition. So this is quite nice sentence. So basically, it's an object is an abstraction that can contain multiple attributes that are contextually linked between each other. So for example, the easiest one would be a file object, which can contain the file name, the different hashes that can have this object, the size of the object, the file itself, so the content itself, and so on. You can also have a person object or a phone object, which can have multiple attributes. Then you have object references, which are a way to link and to add relationship between objects and attributes. And then you have these others that we've talked about. So the proposals, so it's a way to an organization to propose an edit or to propose or to request a change or an addition to an event. Sightings, to say that you've seen something or you notice an activity on something. An event report, which is quite new. It's a supporting material for analysts to describe different things. So it's a more complex attribute of comment type, basically, where you can really express a lot of things. You can put text formatting in it. It's support markdown, and also you can reference the different data that you have or context that you have in your instance. So if you have time, we will see and we'll go over it. So now that we've enumerated all of this data layer, you will see how it's laid down in the platform. So as we say, event on our encapsulation for contextually linked information. So that is what an event looks like in MISP. So you have the title of the event and then a bunch of additional meta information. And you can also notice that you can also attach some context to the event itself. So in that case, we've attached some tags like the TLP and the source of the data itself and the type of incident that this event is about. So yeah, so right now it's quite empty, but we will see that it can get quite full. So we'll skip. This is the JSON representation of an event. It's not really important for this session. So now let's jump to the attributes. So attributes are individual data points and then can be either indicators or supporting data. So this is how it looks like in MISP. So basically you have a table at the bottom of an event. And you have all these attributes which are represented as an entry in this table. So you can have domains, IP source, and so on. So these examples are more related to the cyber world, but it can be basically anything. So it could also be first name, credit card number, and so on. So you have this event, and you can see that this event has some metadata attached to it, and it can also contain attributes. Now let's jump to object. So you've seen this screenshot already in the presentation. So this is a file object which contains some attributes. So you have the file name, the size of this object, the different hashes, and so on. So you can see that all of these attributes are contextually linked between each other, and they can be grouped into an object that makes sense. So that's what you have here. Now, in this event, you have some attributes, but also we have one object which contains different attributes. Now for object references, so this is the way to create a graph in MISP, so to add relationship between entities. So what we have here is an object that references a screenshot and that references other objects. And inside an event, it will be represented with this arrow. So an object can reference attributes, but it can also reference other objects. And then now that we've seen a bit about the data layer, we also have the context layer. So you've seen that you can attach context to an event with tags or galaxies, but you can also attach it to attributes, of course. Now for the sightings, it's really similar to the context. It can also be viewed as a context in itself. Because it also gets attached to a data point. So in MISP, you can also only attach sightings to attributes. But yeah, that's how you can add a time component to an attribute. And then event reports, which are the enhanced comment field. So you can see that this is a report from a blog post. And you can see that it supports Markdown, so you can add formatting, you can add code, and you can also reference different attributes and objects that are contained into this event, but also the context itself. So you can have this interactive report where if you reference, for example, this trade actor, you can click on it and see a description of the trade actor and so on. So it's really nice whenever you have a full report to share, to do it, because it allows analysts and anyone that want to understand what you want to describe to immediately see and understand what you mean. And so in the end, you end up with this event where we also added the proposal entry. So any suggestion made by other organization to your event that you can either accept or decline, and the event report. And finally, the big picture, you can also have correlation, which are described with this arrow. And correlation happened between different events. So you will not have correlation inside an event because it doesn't really make sense. And if you want really to create a correlation, you'd better use a relationship instead. So a relationship or reference like this. And correlation are built automatically across event. So it's a way for you to to understand and to see similarities between different incident or event. Yes, we can skip this. For the context, when we talk about context, it's basically tags, but we have different level of tags, let's say. So we have the free text tags, which are just free text label that you can create and attach to basically nearly any data point, so mainly event and attributes. And these tags, which are free text, can also come from a set of vocabulary, which we call taxonomies. So that you ensure, if you use a taxonomy, you ensure that everyone is speaking the same language. So in that case, instead of having free text, you make sure that all the tags looks the same and that everyone can understand them. And then you have the third context, which is even more advanced than the taxonomy. And this is the galaxy and galaxy clusters. So galaxies are similar to what events are to attributes, basically, in that it's also a container, a galaxy, that contains galaxy clusters. So basically, a galaxy cluster is a tag coming from a common set of vocabularies, which contain additional meta information. So in that case, for example, the galaxy country Luxembourg, this is a tag. But it also contains meta information like the country code, the currency used, the language spoken, and so on. Same for trade actor. You can also have the different synonyms of this trade actor, the different targets that this trade actor is targeting, and so on. So you can attach a bunch of information to these tags. So the reason why we created these taxonomies is because of this main issue. So if you let users create tags, free text tags, you will end up in this situation where everyone is being very creative and they will think that, yeah, that's how you should enter it. But in the end, when you receive all of these tags written in a different way, it's very hard to automate and sometimes to understand what it means. So in that case, you clearly understand what it means, but to automate it, it's much more difficult, especially if you want to set up filtering rules via either the API or the synchronization. So that's why we created this taxonomy, so the common set of vocabularies. This one is the example for the workflow taxonomy, where you can have the different state of advancement whenever you are entering a report in the platform. And then finally, the galaxy clusters. So it's also a tag, but it also contains a lot of meta information. So we can skip this, not really interesting. Just this one, which can be interesting, is a different way to represent galaxy and galaxy clusters. You can represent it in a matrix-like layout, where you can have the different kill chain described. So in that case, we have it for the attack from Maitre. This one is well known, but you can also have it apply for different concepts. For example, we have one for the attack for fraud, which consists in the different steps that an attacker can take and do whenever you have an election, or different fraud for the financial sector. But we also have one dedicated to the telco. We'll cover it in just a few slides. Yeah, that's not really interesting for our case. Okay, so now let's go back to our presentation, our initial presentation, and let's check what we have in MISP specific to GSMA and to the telco sector. So for taxonomy, we have three that I noticed that are already used. The GSMA attack category. Yeah, so it's pretty it says what it's meant to do. Same for the GSMA fraud, so which cover various aspects of fraud that you can have in this context. And the network technology, which is meant to describe the different type of infrastructure that you have. Now for the Galaxy, and especially the Galaxy Matrix, I've mentioned the BADRA framework. This is a threat modeling framework for the mobile communication system. So if you're interested more, this is the paper that we use to generate this Galaxy Matrix. So feel free to have a look. And it basically describes the different steps that an attacker can take in the telco and mobile communication systems. And finally, so this was for the context, but now for the data layer, we have some telco-specific MISP objects. So, for example, the phone, which allows users to describe a phone. So the brand, the email, the MC serial number, and so on. Same for SMSs and SS7 attacks. Yeah, that was a bit fast. As closing note, because we are really approaching the end of the session, I will just provide you some links which can be useful for you. So if you're not familiar with MISP and want to try it out, we have a virtual machine that you can download and run using VirtualBox. All the slides that we produced are available online at this location in the Git repository. So you have access to both the source file. So if you want to compile it and do a presentation for your organization, you can do it freely. But also you have the compiled version with the PDF so that you can immediately see and look at them. So again, we'll also share the slide that we've shown today with Leonie. It can be especially useful for the different taxonomies, galaxies, and objects that are available so that you can have a look at these. Yeah, and I think that's pretty much it.
Wow,
so I will let the floor to Leonie to do the closing.
Okay, so a lot to get through. Really, really appreciate Andres and Sami for going through all of that. And I'm really glad that we've recorded it because I'm sure there's going to be bits for people to delve into. Thank you so much for joining us today. Sami and Andres have said they'll stay on if you want to ask questions, if you're not moving on to another call or meeting. So we will stay on for another 5-10 minutes, depending on whether or not you want to ask any questions without recording. But thanks again for everybody attending, and Sami and Andres, brilliant presentation. Thank you.